You might be thinking why there are so many laws. Let me ask you a simple question. Have you and your friend ever solved the same question only to arrive at wildly different answers? Laws help us to decide who is right. Remember, we have seen the associative law under addition before. A plus B plus C equals to A plus B plus C. Remove all the signs of addition from it to let these matrices have a multiplicative relationship. A into B into C equals to A into B into C. This is the associative law under multiplication. Simple enough, no? We will be proving it by the same method we used for addition. That is, by taking the left hand side and the right hand side one by one, solving them to find their results, and then comparing them to check for equality. Let's start by taking matrices A, B and C, all 2 by 2 matrices. Taking the left hand side, A into B into C, and by following convention, we solve the brackets first. That is, finding A into B. Their orders are 2 by 2 and 2 by 2 again, which tells us two things. 1. Their multiplication is possible, and 2. The order of upcoming A into B will also be 2 by 2. For this, make an empty bracket to the right with 4 vacant positions to fill. The positions are 1 1, 1 2, 2 1 and 2 2. The first value represents the rows and the second one is for the columns. So, when I take the first row of A and multiply it by the first column of B, the result will come here at 1 1. At 1 1, we get 2 times 0 plus 3 times 3. Now, multiply the first row with the second column and write the answer here, 1 2. You get 2 by 1 plus 3 by 1. Similarly, take the second row and the first column. Multiply the numbers -1 into 0 plus 0 into 3 and place them at the 2 1 position. Finally, the second row second column on 2 2 position contains -1 into 1 plus 0 into 1. By further math, this is your A into B matrix now. We were solving for A into B times C. So this result of A into B is to be multiplied by C now. Note that because A into B is written on the left side, A into B matrix is written on the left, and then we have C, so matrix C is on the right. Follow the same procedure. First row, first column has 9 into 2 plus 5 into -1. Then first row, second column, 9 into 2 plus 5 into 0. Then second row, first column, 0 into 2 plus -1 into -1. Then finally, second row, second column, 0 multiplied by 2 plus -1 into 0. Solve the rest and we have solved the left hand side, A into B times C, 13, 18, 1 and 0. Are you following me so far? Now, take the right hand side, A into B into C. Always solve the brackets first. So, we have B and C matrices here. First row, first column, first row, second column, second row, first column, and second row, second column. After solving, we have -1, 0, 5 and 6. Now we need to multiply A into BC. Note that since A is written at the left and BC at the right, you will place the respective matrices accordingly. By multiplying them, we get 2 into -1 plus 3 into 5, and 2 by 0 plus 3 into 6 comes in the first row. Then you have -1 into -1 plus 0 by 5, and -1 multiplied by 0 plus 0 into 6 in the second row. After solving these numbers, we get A times B into C. Now, it's time to compare both the results of left hand side and right hand side. As you can see that both are equal, we can say that the associative law under multiplication of matrices is verified. To recap, we discussed the associative law under multiplication on matrices. In simpler words, it says A into B times C equals A times B into C. That the order in which you multiply three matrices does not affect your final matrix.